Welcome to the world of prompt engineering, where the way you ask questions can dramatically change the quality of answers you get from large language models. In this module, we'll explore advanced techniques that help you get more accurate, reliable, and production-ready outputs from AI systems. Whether you're building chatbots, automating workflows, or extracting structured data, mastering these prompt strategies is essential. Let's dive in and discover how to guide AI models with precision, creativity, and control, starting with the basics and moving into specialized frameworks that professionals use every day. Chain of thought, or COTI, prompting is a powerful method for improving the reasoning accuracy of language models. Instead of asking for a direct answer, you instruct the model to break down a complex task into explicit step-by-step logical rationales. This approach forces the model to dedicate attention to intermediary steps, which helps prevent logical leaps and simple errors. For example, when auditing a company's balance sheet, you prompt the model to analyze revenue, list expenses, subtract them, and then compute the profit margin. This method mirrors how humans solve problems and leads to more reliable outputs. Prompting can take several forms: zero-shot, one-shot, and few-shot. Zero-shot means you provide only the instruction with no examples. One-shot includes a single example to show the desired style or format. Few-shot gives multiple examples, establishing a clear pattern for the model to follow. For instance, if you want to tag customer complaints, a zero-shot prompt might simply ask for a tag. With few-shot, you provide several input-output pairs, helping the model instantly recognize and apply the correct pattern. These techniques are foundational for customizing model behavior. Role-based prompting assigns a specific persona to the model within the system prompt. This technique steers the model's internal attention toward particular vocabularies, tones, and professional standards. For example, asking an LLM to review code as a principal security engineer will prompt it to proactively scan for deep security exploits, rather than giving generic feedback. By defining the role, you can dramatically change the depth and focus of the model's responses, making outputs more relevant to specialized tasks. Ensuring that a language model returns output in a valid, production-ready JSON format requires careful prompt design. You can combine explicit markdown delimiters, a strict schema in the instructions, and a few-shot example. Enabling native API schema constraints, like OpenAI's JSON mode, further enforces structure. For instance, when extracting user information, you specify the required keys and formats, and instruct the model to avoid conversational text. This approach prevents backend parsers from crashing due to unexpected output. RAACT, reasoning and acting prompting pattern, guides the model through a continuous loop of thought, action, and observation. The model analyzes the problem, calls an external tool or API, observes the output, and repeats this process until the task is solved. For example, a travel assistant agent might process a flight booking by first seeking real-time prices, then selecting the cheapest option based on the return data. This framework enables dynamic, tool-augmented reasoning for complex tasks. Self-consistency prompting involves querying the model multiple times at a higher temperature to generate diverse reasoning paths for the same question. The final answer is chosen by majority vote among the outputs. This technique smooths out random generation errors and increases reliability. For example, in automated code grading, running the model several times and selecting the most common result ensures a more robust evaluation, especially for complex algorithmic tasks. You place instructions in a prompt can significantly affect the model's output. Due to attention primacy and recency effects, critical rules placed in the middle of a long prompt may be ignored. It's best to put core operational instructions at the very beginning or end of the input. For example, if you append a lengthy document and put your question at the top, the model may forget it by the end. Placing the question after the document keeps it fresh in the model's attention. Limiters are structural tags, like HTML or XML tags, used to clearly separate instructions from user inputs or context data. They are vital for secure prompt design, preventing the model from confusing data with instructions. For example, in a translation app, wrapping user input in user text tags ensures the model treats it as data to translate, not as a command. This simple technique helps avoid prompt injection and keeps outputs predictable. Directional stimulus prompting involves providing a small, targeted hint or cue alongside the main input to steer the model's focus. This technique is especially useful when you want to highlight specific aspects of a complex task. For example, when summarizing a long meeting transcript, you can add a focus like product launch delays and budget overruns. This ensures the summary emphasizes those points, rather than getting lost in unrelated detail. Tree of thoughts to T framework extends chain of thought by allowing the model to explore multiple branches of reasoning at once. The model evaluates its progress at each step and can backtrack if a branch leads to a dead end. For example, when solving a logistics routing puzzle, the model proposes several routes, evaluates costs, and shifts focus if one path exceeds the budget. This approach enables more flexible and thorough problem solving. Prompt drift occurs when updates to a model's backend weights cause existing prompts to change their formatting or output quality. To handle this, maintain a continuous evaluation suite with deterministic test cases, version control your prompts, and set up automated alerts for schema failures. For example, if an API update causes the model to output markdown code blocks instead of raw JSON, your system can catch and address the issue before it impacts production. Generated knowledge prompting asks the model to first generate a list of relevant facts, rules, or background concepts before producing its final answer. This technique anchors the model's reasoning in concrete information, reducing hallucinations. For example, when critiquing a complex tax scheme, you prompt the model to list core regulations first, then use those facts to evaluate the scheme. This structured approach leads to more accurate and grounded outputs. Stop a model from outputting generic AI disclaimers like, "As an AI, I'm not a financial advisor." you need to ground the task in a clear hypothetical context and add explicit negative constraints. For example, in a simulation app, you specify that the model is running in a closed sandbox for training, and instruct it not to include any meta text or disclaimers. This keeps outputs focused and professional, avoiding unnecessary boilerplate. Meta prompting is the practice of using a highly capable model to automatically write, structure, and optimize prompts for other models. You provide a basic description of the task, and the meta prompting template generates a production-grade prompt, complete with formatting, delimiters, and error handling rules. For example, an engineering manager might request a prompt for extracting names from emails, and the system outputs a ready-to-use template. This accelerates prompt development and ensures best practices. Explicit XML tags are often superior to markdown headers in complex prompts. Many models are fine-tuned on web data wrapped in structured markup, making it easier for them to isolate specific blocks of text. For example, in a retrieval-augmented generation, RAG pipeline wrapping documentation snippets in XML tags allows the model to cite exact sources, simplifying automated tracking. This structure enhances both accuracy and traceability. Least to most prompting technique breaks down a complex problem into a series of smaller subproblems, solving each one sequentially. Each solution is passed along to help solve the next, more challenging step. For example, when generating a large codebase, you first prompt for database schemas, then use that output to draft backend controllers, and finally integrate everything into the front end. This stepwise approach builds complexity gradually and reliably. Prompting a model to evaluate its own output before finalizing the response can greatly improve quality. You set up a critique and refine loop in the prompt, requiring the model to audit its draft against a checklist of rules. If any rule is violated, the model rewrites the draft before outputting the final approved text. For example, after drafting a meeting summary, the model checks for compliance and only outputs the clean version. This process ensures higher accuracy and adherence to standards. Negative prompting or constraint reinforcement explicitly tells the model what not to include in its output. However, because language models predict the next token, mentioning forbidden words can sometimes make them more likely to appear. To be effective, place negative constraints at the very end of the prompt and use clear formatting. For example, to avoid the word premium, you state, "Critical constraint, do not use the word premium." This reduces the chance of accidental inclusion. Illogical prompting instructs the model to recall or generate its own relevant examples of similar problems and solutions before tackling the user's specific problem. For instance, when solving a difficult math word problem, you ask the model to write out and solve two similar examples first. This primes the model's internal weights, aligning its reasoning with the correct patterns and improving the quality of the final solution. In designing data extraction prompts, it's crucial to handle cases where the target information is missing. Without explicit fallback instructions, the model may guess or hallucinate an answer. For example, in a resume parser, you instruct the model, if no get link is mentioned, return exactly an A. This prevents the model from inventing plausible but incorrect data, ensuring your outputs remain trustworthy and consistent. Let's revisit chain of thought with a real-world example. Imagine you're auditing a company's balance sheet. Instead of simply asking for the net profit margin, you prompt the model to analyze revenue, list expenses step by step, subtract them, and then calculate the margin. This not only reduces the risk of simple math errors, but also mirrors the logical process a human auditor would follow, resulting in more accurate and trustworthy outputs. Consider the task of tagging customer complaints. With zero-shot prompting, you simply ask the model to tag a complaint like "my screen is cracked." With few-shot, you provide several examples such as "I want a refund" tagged as financial or "the app keeps crashing" tagged as tech bug. The model quickly learns the pattern and applies it to new inputs, demonstrating the power of example-driven prompting. Role-based prompting can transform generic outputs into highly specialized responses. For example, if you ask an LLM to review code, it might give basic feedback. But if you specify that it's acting as a principal security engineer, it will proactively look for deep security issues like buffer overflows and SQL injections. This technique ensures the model's output matches the expertise and standards required for the task. Production systems, enforcing strict JSON output is critical. For instance, when extracting user info, you instruct the model to return only a JSON object with specific keys and to avoid any conversational text. This ensures your backend systems can reliably parse the output, preventing crashes and data errors. Combining schema instructions with few-shot examples further strengthens this enforcement. React framework shines in scenarios like travel booking. Suppose you prompt an agent to book the cheapest flight from NYC to London. The model first thinks about what it needs, calls a flight search API, observes the return prices, and then selects the cheapest option. This loop of thought, action, and observation enables the model to handle dynamic, real-world tasks efficiently. Self-consistency prompting is valuable in automated code grading. By running the model multiple times at a higher temperature, you generate diverse reasoning paths. If most runs agree on a result, like a code's runtime complexity, you select the majority answer. This approach smooths out random errors and leads to more reliable grading, especially for challenging algorithmic problems. Imagine you have a 10,000-word context document and a specific question. If you place the question at the top, the model may lose track of it by the end. By placing the question after the document, you ensure it remains fresh in the model's attention, increasing the likelihood of a relevant and accurate answer. Proper instruction placement is a subtle but powerful prompt engineering skill. Using delimiters like user text tags is essential for preventing prompt injection attacks. For example, if a user tries to trick a translation app by entering a command instead of text, delimiters make it clear to the model that the input is data, not an instruction. This simple practice keeps your applications secure and your outputs reliable. In summarizing complex documents, a directional stimulus can guide the model to focus on what matters most. For example, adding key focus, product launch delays, and budget overruns ensures the summary highlights those issues. This technique is especially useful for long or multifaceted inputs, helping you get concise and relevant outputs. Tree of Thought's framework is ideal for solving complex logistics problems. The model explores multiple shipping routes, evaluates costs at each step, and backtracks if a route becomes too expensive. This branching approach allows the model to find optimal solutions by considering several possibilities in parallel, rather than sticking to a single path. Prompt drift can disrupt production systems when model updates change output formats. For example, if an API update causes the model to output markdown code blocks instead of plain JSON, your backend may break. By maintaining evaluation suites, version control, and automated alerts, you can quickly detect and fix these issues, ensuring system stability. For asking a model to critique a complex topic, have it generate a list of relevant facts or rules. For example, when evaluating a tax shelter scheme, prompt the model to list IRS regulations first. This anchors the critique in real information, reducing hallucinations and making the analysis more trustworthy and fact-based. In training simulations, it's important to prevent the model from outputting AI disclaimers. By specifying a sandbox environment and banning metatext, you ensure the model delivers focused, actionable outputs. This keeps the simulation realistic and free from unnecessary interruptions, enhancing the learning experience. Metaprompting accelerates prompt development by letting a capable model generate optimized prompts for you. You describe the task, and the system outputs a ready-to-use template with best practices built in. This saves time, reduces errors, and ensures consistency across your AI applications. Using XML tags in prompts makes it easier for models to isolate and cite specific information. For example, in a documentation retrieval system, wrapping each snippet in XML allows the model to reference exact sources. This structure is especially useful for complex tasks that require traceability and precise source attribution. In generating a large codebase, the least to most technique helps manage complexity. Start by prompting for database schemas, then use that output to generate backend controllers, and finally integrate everything into the frontend. This sequential approach builds up the solution step by step, making the process manageable and reliable. Critique and refine loop improves output quality by requiring the model to audit its own drafts. For example, after drafting a meeting summary, the model checks it against compliance rules and rewrites if necessary. Only the final approved text is output. This process ensures higher standards and reduces errors in sensitive applications. In writing product descriptions, negative prompting can help avoid forbidden words. For example, instructing the model not to use premium by placing this constraint at the end of the prompt reduces the chance of accidental inclusion. However, be aware that mentioning forbidden words can sometimes make them more likely to appear, so always test and refine your prompts. Analogical prompting is especially useful for complex problem-solving, like math word problems. By asking the model to generate and solve similar examples before tackling the main question, you help it align its reasoning and avoid mistakes. This technique leverages the model's ability to learn from patterns and apply them to new situations. Explicit fallback instructions are essential in data extraction prompts. If the target information is missing, the model should return a specific value like NA instead of guessing. This prevents hallucinated data and keeps your outputs consistent and trustworthy, especially in automated systems where accuracy is critical. Throughout this module, we've covered the essential techniques of prompt engineering, from chain of thought and React to metaprompting and fallback instructions. Each method helps you guide language models more effectively, ensuring outputs are accurate, relevant, and production-ready. By mastering these strategies, you can unlock the full potential of AI in your applications, making your systems smarter, safer, and more reliable. Let's recap the best practices for prompt engineering. Always use clear instructions, provide examples when possible, enforce strict output formats, and handle edge cases with explicit rules. Place critical instructions at the start or end of your prompts, and use delimiters to separate data from commands. Regularly test and update your prompts to adapt to model changes and prevent drift. These habits will help you maintain high-quality AI output. Prompt engineering isn't just a technical skill, it has real-world impact. From automating business processes to enhancing customer support and ensuring data integrity, the way you design prompts can make or break your AI solutions. By applying these techniques, you'll build systems that are not only smarter but also more robust and user-friendly, driving better outcomes for your organization. Now that you've learned the core techniques of prompt engineering, it's time to put them into practice. Experiment with different strategies, refine your prompts, and monitor your outputs closely. Stay updated with the latest advancements in AI and prompt design, and continue to iterate for even better results. With these skills, you're well equipped to tackle complex challenges and innovate in the rapidly evolving world of AI.